Hello everyone. In this video, I am going to solve one objective bit given in the electrochemistry chapter. Now let us read down this question first. For the given cell, copper solid bar Cu2 plus of C1 concentration, and then this is the salt bridge Cu2 plus of C2 concentration bar copper solid. The change in the Gibbs energy delta G is negative if C2 is equal to root 2 C1, C2 is equal to C1 by root 2, C1 is equal to 2C2, and C1 is equal to C2. See here, in this particular question, copper, this is an electrode. Here also copper is also electrode. That means two electrodes of the same metal, two electrodes of the same metal, two electrodes of the same metal. And then see, the metal is copper here, and you have a metal ions of different concentrations, same metal ions of different concentration. Same metal is there, same metal ions of different concentrations are there. So therefore, the two electrodes of the same metal are dipping in a solution of metal ions of different concentrations. Metal ions of different concentrations. Metal ions of different concentrations are called electrolyte concentration cell. Are called electrolyte concentration cell. Electrolyte concentration cell. So this given example is an electrolyte concentration cell. The EMF of the electrolyte concentration cell directly we can write down like this. E is equal to 0.0591 by 2 log C2 by C1 to base 10. So this is the formula for the electrolyte concentration cell. We can also derive this formula. After completing this bit, we'll derive the formula for this EMF. Okay, now let us solve this question. Let us write down the fourth option. First, if C1 is equal to, if C1 is equal to C2, then that implies E is equal to 0.0591 by 2 log C1 by C1 to base 10. C1 gets cancelled. That is equal to 0.0591 by 2 log 1. And we know that log 1 is equal to 0 and this answer will be 0. That implies delta G is equal to 0. But we want delta G should be negative. So the concept is if delta G is negative, then EMF should be positive. EMF should be positive. Because we have the formula delta G is equal to minus NFE. So if the EMF is positive, then only delta G is negative. So therefore, what we have to do is that we have to check in which option that E is positive. So in the fourth option, delta G is equal to 0. Let us go to the third option. In the third option, if C1 is equal to 2C2, then that implies E is equal to 0.0591 by 2 log C2 by 2C2. Now this is log 1 by 2. So 0.0591 by 2 log 1 by 2. That is equal to minus 0.015 by 2 log 2. And that is equal to minus 0.0591 by 2 log 2 is 0.3010. So therefore, this answer turns out to be negative. Then that implies delta G is positive. So therefore, again, this option is wrong. Let us go to the second option. Now, if C2 is equal to C1 by root 2. Now that implies E is equal to 0.0591 by 2 log C2 is equal to C1 by root 2. So C1 by root 2, C1. C1 gets cancels. That is equal to 0.0591 by 2 log 1 by root 2. Log 1 by root 2, we can write down this as minus right here, and this is 2 to the power of half. That is equal to minus 0.0591 by 2 into half into log 2. And again, this answer, log 2 is again 0.3010. This is 0.3010. And again, because you have a negative value, this answer turns out to be negative. Now that implies delta G is equal to positive. Again, in this case, delta G is positive. The second option is also wrong. Now let us go to the first option. The first option is C2 is equal to root 2 C1. So the first option C2 is equal to root 2 C1. Now that implies E is equal to 0.0591 by 2 log to base 10 root 2 C1 by C1. C1 gets cancels. That is equal to 0.0591 by 2 log 2 to the power of half to base 10. That is equal to 0.0591 by 2 into 1 by 2 into log 2. That is equal to 0.0591 by 4 log 2. So that is equal to 0.0591 by 4 into 0.3010. Now this value turns out to be positive. Therefore, EMF is positive. EMF is positive. EMF is positive. Therefore, delta G is negative. So delta G is negative only in this case. Therefore, the answer is 1. Answer is 1. So the first option is correct now. Now let us try to solve the derivation of this equation. Let us derive the formula for this given electrolyte concentration cell. So the given electrolyte concentration cell is Cu solid bar Cu2 plus of C1 concentration whole divided. This is the salt bridge, and Cu2 plus of C2 concentration by Cu solid. So this is an electrolyte concentration, as I already told you, and this is the right hand electrode where the reduction takes place, and this is the left hand electrode where the oxidation takes place. So now here let us write down the EL. EL is equal to E0 of Cu2 plus bar Cu minus 0.0591 by 2. See here oxidation takes place. So this is the oxidation reaction. Cu give rise to Cu2 plus 2E minus. So this is the solid and this is C1 concentration. But once you write the Nernst equation, we'll write in the reduction form. Cu2 plus 2E minus give rise to Cu. So this is a C1 as well as this is a solid. So therefore this equation becomes, EL becomes 0.0591 by 2. And then we'll take this copper solid as 1. So 1 by, and this becomes C1 to base 10. So this is log 1 by C1 to base 10. This is log 1 by C1 to base 10. Log 1 by C1 to base 10. So this is the EMF for the left hand electrode. And let us come to the right hand electrode. So in the right hand electrode, there is a reduction reaction. It's very clear. So this is C2 plus 2E minus gives rise to Cu. Therefore, E is equal to E0 of Cu2 plus bar Cu. And this is right hand electrode, ER, minus 0.0591 by 2 log, again, 1 by C2 concentration to base 10. So this is the equation for the ER. Now, therefore, the EMF of the cell is equal to ER minus EL. Now that turns out to be, first let us write down the ER. ER is this. So E0 of Cu2 plus bar Cu minus 0.0591 by 2 log 1 by C2 to base 10, and then minus of E0 of Cu2 plus bar Cu2 plus bar Cu minus 0.0591 by 2 log 1 by C1 to base 10. So therefore that implies E is equal to, and then this is E0 of Cu2 plus bar Cu minus 0.0591 by 2 log 1 by C2 to base 10 minus E0 of Cu2 plus bar Cu minus of minus plus, this is 0.0591 by 2 and then log 1 by C1. So E0 gets cancels, and then this becomes, this is equal to 0.0591 by 2 log 1 by C1 minus log 1 by C2. Now that implies log 0.0591 by 2 log 1 by C1 by 1 by C2 to base 10. Therefore, that implies E is equal to 0.0591 by 2 log C2 by C1 to base 10. So this is how we have to derive the formula for the electrolyte concentration cell. The question is a very interesting question. I hope all of you understood how to solve this question. So in the next video, we'll solve another interesting question. Thank you very much.